Good morning, everyone. Today I'm going to talk about section 2.5, motion with a constant acceleration. And I believe this section is one of the most important section of the, entire, semester. So you have to see, listen this lecture very, very carefully because we got to use this one, during the entire, rest of the entire semester and next semester as well. Okay. And then motion with the constant acceleration. So I will introduce basically five new equations. Okay, and then these equations only for constant acceleration. So don't just use that equations, five equations, unless the acceleration is a constant. Okay, so the acceleration definition is straightforward, right? In VT graph, the slope is your acceleration, right? And then of course, acceleration definition is velocity changes over time. So if you multiply delta t both side, you see at here. And then if you move xi to the left side, you see v final is gonna be v initial plus acceleration times the time, right? So this is one of the equation, but we can if you see your textbook, you can check how you drive all five equations, but at this point, that's not very important, okay? And then also another physical meaning of velocity versus the time graph is the area under the graph is a displacement x. This is simply because let's assume instead of having this VT graph, let's assume you have acceleration, you have a velocity, sorry, this is your velocity. And then let's assume a constant velocity motion. So then, what is your displacement? Your displacement is simply velocity times the time, right? So that is the area under the graph. This is the area. This is simply v, which is height, times t, which is width, right? This is time, right? Sorry, this is not a acceleration axis. This is time axis, right? So that area is gonna be your displacement on that VT graph, right? And then you can also drive this equation, but again, that's not important at this point. You can also carefully check your textbook to drive, to see how you drive these equations, right? And then there's another equation, and then total, the textbook will introduce only five equations. In other words, this is equation number one in the textbook. This is number two in the textbook. This is number three in the textbook. But I will introduce two more, so total five, which is not shown in the textbook. But you will see why this method, works better. I'll explain it. So again, these three are the equations in the textbook. So let's see this parameter slides very carefully. So basically, you see this is one of the equation in the textbook, and the other one is this one, and then here is this one, right? But I introduced two more new equations, okay? And then let's think about what they, how to use these. And then if you see these equation very carefully, there are total of five variables, right? Delta x is the displacement. Vi, sometimes, textbook use a V initial, so that is the initial velocity. So B is the V final velocity. So sometimes we use a V or V final. In this slide, I use the V, but what it means is a V final. And then acceleration is A, right? This is acceleration. And then because we assume the constant acceleration, right? So there's no there's no initial acceleration or final acceleration. We don't have it because the acceleration is a constant. And then of course, t is time. So then you see again, we have a total five variables, right? So far so good, right? And then next thing is four variables for each equation. In other words, if you see equation number one consists of a v final, v initial, a t. So only four variables, right? And then how about equation number two, for example? It has a delta x, initial velocity, time, and acceleration. So time again. So this is also four variables again. If you see equation number three, delta x, final velocity, time, and acceleration, another four variables, right? So then you can check number 4 and 5. You see there are only four variables for each equations, right? So then you will be given three variables. This is a very important concept. So let's assume, for example, equation number one is a v final, or v is a v0 or v initial plus a at. But now let's assume you are looking for v final. The question is, the problem asks you to find what is a v final. So in order to find v final, what do you need? You need a vi and a t. So if vi, a, t, these three values are given, you can find the v final, right? Because this is a, let's say this is a 3 plus 2 times 2. So then you can find the v final, 7, right? So in order to find one variables out of four variables, again, remember each equation consists of four variables, right? So if 3 is given, you can find the last one, right? So this is a very important concept. This is a key idea of our entire, this section. So find an equation that does not contain the three variables and one variable you are looking for. So that means, again, each equation is what? Consists of four variables, right? So then you have to find one equation that consists of three known value and then one unknown that you are looking for, right? So then you can always find out these unknowns, right? So in other words, each equation has a one missing variables, right? Because again, each equation consists of four variables, right? So for example, equation number one doesn't have a delta x, and equation number two doesn't have a v final. Equation number three doesn't have a v initial. So then now let's assume you have an equation consists of four variables, right? And then three of them that is known value, let's say is a delta x, v0, and v in the first three. And then the one that you don't know or you're looking for is a. So then now your equation is about these four values. So it's nothing about t at this point, right? So then you find the equation that doesn't have a t. For example, equation number 5. Equation number 5 doesn't have a t, but you are looking for a while knowing delta x, v, and then v0. So then you can find a simply, right? So this is a basic principle. This is why I introduced 5 equation instead of 3. And then the example here, for example, think about this quiz very carefully. Pause the video. Okay, think about it. And then, okay, if you are given x0, v initial, v final, and you are looking for a, which equation will you use? So then now, x0, delta x, v0, v final, acceleration, you're interested in these two, four parameters, and then basically, what is the missing parameter? It is a time. So then you gotta use the equation number 5, right? T is missing, use equation number 5. And then another key is, now here we have a v0, v and A are known, respectively 1, 3, 1. And then what is a T? So you are looking for T. So which parameters are irrelevant? For this case, delta X is missing. So you gotta use the equation number 1, right? Equation number 1 doesn't have X, while you know V0, VA. So then now you simply use this V0, right? Equation number 1. What is the V? They said V is a 3, and then V0 is a 1, plus I think they said 1, right? And then T, you don't know, right? So then you see T is gonna be 2, right? Right? And then after you find the T, so now T is now known as well, right? Because initially you know these 3 only, but now you find the T as well. So now you have a 4 knowns, 1 unknown, which is what? Delta X, right? So then now you can use any equation except equation number 1 to find what? Delta X, right? So for example, if you use, feel free to choose anyone, right? So if you use equation number 2, delta X is a simply what? V0, which is a 1, times a T we found is 2, plus 1 half times A, they said 1, times a T square, which is 4. So your displacement is 2 plus 2, which is 4. So then at the end, you know all 5 variables. So in other words, basically these 5 equations consist of all 5 variables. And your final goal is to find all these 5 variables, right? But initially, you know, randomly 3 of them are given. And then you choose the equation that, first equation, asks you to find. Then you choose the equation having these 4 parameters or equation without T. So then you find A, and at the end now you have 4 unknowns. Now the last parameters is your last unknown. And then choose another equation to find the T. So at the end, you initially start 3 known parameters and then finding the other 2. So at the end, you know all 5. Okay, so here's the example. So the important part of this question is always the very first step is to find 3 given variables, right? So then now let's see this question very carefully. The rocket accelerates at 20 meter per second square. So your first known, you basically again have 3 knowns, right? Your first known is what? Acceleration. And then how long does it take the rocket to reach a velocity? So how long? So basically your unknown that you're looking for is a time. And then and again, you must have 3 knowns, right? So you must have the other 2 knowns, right? The easiest one you can find immediately is what? 400 meter per second. It reach a velocity 400 meter per second. So that means it's a final velocity v is a 400 meter per second. So it seems like you have only 2 knowns, but this is a typical. In general, some known values are hidden. So you have to find it, right? So what is one more known value? So we have 3 values, known or unknown. So basically there are 2 candidates, right? What is that? Delta X or V final. V initial, right? V0 or V initial. So which one is given in the problem? Of course, this is a V0 because why? The rocket will start from 0 velocity. So this is a hidden known value. So then now you see, okay, I have a V final, V initial, and then I'm looking for T. So what is the missing variables here? Delta x is missing. So then you have to find the equation that doesn't have a delta x. So this is equation number 1. So then now you just insert the numbers. V final, they said, is 400 equals V initial was 0 plus acceleration, they said 20. So t is what you're looking for. So then now you see t is going to be 20 seconds. Right? I hope everybody now understand this principle. This is again extremely important slides. Okay. You have to let me know if you have a question. And then now we see, okay, I have acceleration 20, initial velocity 0, final velocity 400, time 20. So now we have about 4 variables, right? So then what is missing? Delta x is our fifth unknowns. So in order to completely solve this question, we have to find delta x as well. In general, sometimes the problem asks you to find one of the two unknowns, but sometimes they ask you find both, right? So always make sure you can find the last one as well. So I'm going to use equation number 2 again. So delta x is what? V0t. V0 is 0. T is 20 plus 1 up times a. They said is 20. Right? T square is 20 square, which is 400. Right? So delta x again, this is 10. So it's 4,000 meter. You can also calculate delta x if the problem asks you. Right? Another example, as you drive in your car at 15 meter per second, you see a child ball, rolling into the street. You hit the brakes and then stop quickly as you can. In this case, you come to rest in 1.5 seconds, right? How far does your car travel? So then now, again, the very first step is to find the 3 given variables. What is the first? You can see the number clearly, 15 and then 1.5. So 15 is what? Initial velocity, because you were driving at 15 meters per second, right? So this is a V0. And then what else number? You have a 1.5 second, which is a T. And then what are you looking for? How far? So you're looking for delta X, right? So then again, you must be given, 3 variables. So then, which one is not shown here? Acceleration or V final is not shown. So one of these two must be given, right? What is the given? Yes, V final. Why? Because you will stop. So the third given value is this. And then you're looking for delta x. Maybe you can find the delta a as well later, right? So then you have to find the equation that doesn't have acceleration. So that is equation number missing a, this one, right? So then now our delta x is what we are looking for. So delta x is 1/2 initial velocity, final velocity times t. So now don't see the solution. Solution, textbook is, makes you more confusing. So use my method, okay? So our delta x is 1/2 v initial plus v final times t, right? So we are looking for delta x, which is 1/2 times v initial is 0 plus v final is 15. So the v final is 15, v initial is v initial is 15, v final is 0, and the time is 1.5, right? So then if you solve this one, you will see distance is 11 meter. Let me double check it here. Right, everything correct, right? This is 1/2 times 15 times 1.5 is what? 2.3, right? This is 45 divided by 4, which is 1 point, it's about 11 meter, right? So there you see the the displacement is 11 meter. you can also find the acceleration as well here. Now, because we know delta x is 11 meter, right? So now we see delta x is 11 meter. We can find the acceleration as well, right? Using, whatever equation you have here, right? So leave it, for you, this question to see if acceleration is minus 10. Make sure you can get it, okay? So again, we finally find all 5 variables. And another question, the similar question we have here, we have racer starting from rest. Now you can immediately find our first variable, given variable is v initial is 0. And then it travels 6 meter. So that means delta x is 6 meter. And then in 1 second, right? So our time is 1 second. Done, right? So then what is the two unknown variables here? Acceleration is not given, and then final velocity is not given. So we can find both of them, right? And then suppose the car continues this acceleration for an additional 4 seconds. So then now, okay, because basically this question consists of two motions, right? If we find A for the first motion, we can use that acceleration for the second motion as well, right? So then let's find what is the A. What is the acceleration? So then you have to use the equation that doesn't have a V final, right? So which equation doesn't have a V final? The C missing V final is the equation number 2, right? Equation number 2, we don't see V final, right? So then now we use in order to find the acceleration, we can do, delta x. We'll write down, the equation. Delta x is a VIT plus 1/2 times AT squared. So delta x, they said 6 meter. VIT, V initial is 0, right? So VIT is 0 plus 1/2 times A is what we are looking for. And then T is a 2.3/2 square, right? 1.5 square, right? So then if you find the A, you will see, 1 second. Yeah, I think that they didn't find the A directly. So let's go over everything together. So then A is this is a 9/4. So 6 equals 1/2 times A times 9/4. So your A is 8 over 9/8 equals 6. So A is what, 6 times 8, right? So this is 3, 2. So 16/3. That's your acceleration, right? And then you can also find the V final as well, right? How do you find the V final? Now you can use any equation in this 5 equation to find the V final. For example, you can use number 1, V final is a V initial plus AT, right? So then now you see your V final is a V initial, which is again 0, times A we find, and then T is right? So V final is 648, right? So which is what is that? You can cancel here, you can cancel here, which is 8, right? So your V final is 8 meter per second. So then now we have a acceleration, V final 8. So now we have all 5 variables, right? And then now the car continues this acceleration for an additional 4 seconds. So now this is our t. This is again our first variables. And then we are looking for delta x, right? And then because we now only have a t only, we must have 2 more variables, right? What are these 2 more variables? Because they said that they used the same acceleration. So our acceleration for the second motion is a 16 over 3. So this is our second known value. And then what is the third known value? That's the final velocity of the first motion. So the final velocity of first motion is what? Initial velocity of the second motion, right? So then now we have 4a time acceleration and velocity. So then we can find the delta x using what? Equation number. So in other words, this equation doesn't have a v final, right? So then you have to find the equation that doesn't have a v final. Again, equation number 2, right? Doesn't have a v final. So then now we can say our delta x is what? Is a vit plus 1 up times a t squared, right? So our delta x is a vit. Again, vi is not 0 at this point because this is going to be a, right? So it's a times our t is 4 plus 1 up times a t squared, right? So you can find the delta x. But that's not the answer. Why? Because this is the distance for the first motion. And then you have to add this one plus 6, which is the delta x for the first motion, right? And then that's going to be your final answer, right? And then you will see that's going to be 150, and then double check your answer by yourself, okay? So section 2.6 is basically the same what we did here, right? Now we have a rocket round trip straight up with a constant acceleration 18 meter per second. So now it's our first known after 150 seconds. So this is our second known t, how fast the rock moving, right? How fast? So basically you're looking for v final, and then how far we are looking for delta x, right? So, again, sometimes they ask you to find both parameters. So then now which one is not shown, v initial must be given in the problem, even though they didn't mention anything. So, but you can guess v initial is, of course, 0. So now this is a 3 known variables, a, t, vi. You can either find, v final first or x first. It really doesn't matter. Okay, so if you want to use the v final first, use the equation number 1. V final is a v initial, which is 0 plus a 18, t is a 150. Then simply 150 times 18 is gonna be your v final. And then after you find the v final, you can find the delta x, because they said that why? Because this is a vertical motion, but basically you can use the same logic, right? So then now this is a vit. Again, vi is 0, 1 half times up a, t squared. Then you can find the delta x as well, right? So now it's very simple, right? You got to practice, you know, all these examples by yourself, maybe a couple of times, and then you have a fully loaded Boeing engine and acceleration 2.6. This is your first, and then minimum takeoff speed is a 70 meter per second. So this is your V final or V, and then again, so the airplane start from 0 velocity, so you can say v0 is a v0 as well. So again, 3 known variables. So the problem, even though you didn't read the rest of the problem, you can say the problem will ask you how long will it take, and then how far it will travel, right? Then you read the problem, how much time, this is about time, and then what is the minimum length of a runway, this is the distance, right? So again, the same, question over and over, again, the main, idea here is you have to find 3 given variables, and then the other 2, depends on which one you're looking for first, but the order actually, again, doesn't matter. You have to choose one, variables you have to find, and again, 4 variables involved in the problem, and to find the equation, that has that four variables, right? I'm gonna solve this example again. Okay, so the today lecture is extremely important. Okay, make sure, make 100% sure that you understand what we did today. Okay, so this is again, you will use this idea over and over, for the rest of the entire semester. Okay, and let me know if you have any question. Okay, and then I will assign homework 2, soon. Thank you.